Algebra I 9.5b, graphing inequalities in two variables. Now I want you to remember that I've got links in this description, okay? So if you're ever confused as I'm going along, just know in your heart that there's probably a link in this description that will help clear that up, okay? The graph of a linear equation, x plus y equals 3, separates the coordinate plane into three parts. The set of points on the line, the set of points above the line, and the set of points below the line. We call the parts above the line and below the line half planes, and the line itself is called a boundary line. So, if we solved x plus y equals 3, then every point on this line would fit x plus y equals 3. But for x plus y is greater than 3, that would be everything up here in this half plane. And for x plus y is less than 3, it would be everything down here in this half plane. See, if x was 10 and y was 2, 10 plus 2 is 12. Well, that's greater than 3. And any point we pick down here, -4 plus -9 is a -13. That's less than 3, so that's true. So this is a half plane, this is a half plane, that's the boundary line, and all this green area makes that inequality true, and all this pink area makes this inequality true. See? Less than, greater than. So it looks like this. That's our boundary line, and that's where it equals 3. Up here it's greater than, up here it's less than for this particular problem, okay? So each one may be a little bit different, but for that one, x plus y is less than or greater than 3. That's how it would fall. So the solutions for an inequality in two variables are all the points on the half plane that might even include some points on the boundary line, okay? So look at this one. It says graph x plus y is less than 3. So we draw the graph as a dashed line. Well, that shows that the points that are on this line are not solutions for x plus y is less than 3, okay? That's what the dashed line means. The solution is on one side of the boundary line. It's below it. It's this entire pink area. We can test a point that isn't on the line, like the origin, 0, 0, and we try plugging it in. 0 plus 0 is less than 3. Yep. So that means that this is the shaded area that we're going to make, because this is the area, the half plane, that has all the solutions for that inequality. We can make a function table to find the xy values. What we do is we take this inequality and we put an equal sign here and then make a function table for the equals. That way we know where to put the dashed line. You remember how to make a function table, right? So there'll be a link in this description going back to chapter 7. We did that like a month ago, okay? So if x were 3 and y were 0, if x were 3 and y was 0, so that would be this point right here. That's 1 point for the dashed line. And if x were 2 and y were 1, so if x were 2 and y were 1, here would be the next point, and then the next one, and the next one we draw our dashed line, and we shade in the half plane that has all the solutions. See? X plus y is less than 3. 0 plus 0 is less than 3. So we know that's the correct half plane. 0 is less than 3 is true. So it includes the 0, 0 right here, the origin. And we shade it in to show where all the solutions are. See? That's easy, isn't it? All right, look at this one. It says graph y minus 2x is greater than or equal to 0. Now, what you have to realize is that the y is first and then the x is second. So don't make the mistake when you make your function table of putting them in the wrong spot, okay? The y is first in this equation. So we graph and make a function table set for y is y minus 2x equals 0. So we take this away and put an equal sign there to make our function table. So that would be, if y is 2 and x is 1, 2 minus 2 times 1 equals 0. So y being a 2 and x being a 1 would fit that, right? And we make our function table, filling it out for other things that would make this true. And now we've got the points for our line. Now, because it says it's greater than or equal to, it's going to include these points. So we're going to have a solid line. See? It does equal some of them, or greater than. So we use a solid line to show the points on this line are solutions for our inequality. And our solution is above the boundary line and includes the points on the line. So we shade in that half plane that contains the solution, okay? We can determine which half plane contains the solution by testing a point not on the line, like 1, 1. And we put a dot at 1, 1, and then we plug in 1, 1 into this to see if it's true. 1 minus 2 times 1 is not greater than 0. That's false. So that half plane doesn't contain solutions. It's the other one that does. So that's why we knew that this was the half plane that contained the solutions. See? We used a test spot and then plugged that into the inequality to see if it made it true. If it's false, then it's the other half plane, okay? Now this one says, look it just says y is less than -2. That's a very small inequality, isn't it? So we draw the boundary line as y equals -2 as dashes because it's less than, right? It doesn't include the -2, it's really less than it. So we draw a dashed line going across -2 here, and we can plug in a test point that's not on the line, like 0, 1. So this point, x is 0, y is 1, we try plugging that in here. So if y was 1, we would put a 1 here. See? 1 is less than -2. Now, there is no x value, is there? So that's why it's set at 0. When you see something like this and there is no x in the inequality or the equation, well, that means x is 0. All right? So that would be a 0, 1. Plugging 0, 1 into this to see if it's true, it's false, because 1 is not smaller than -2. It's actually bigger. See? So we know it's in this half plane. If this part of the half plane makes it false, then it must be this half plane. So if we try 0 and -4, so y is less than -2. So if we use -4 for y, -4 is less than -2. That's true. So it is in this half plane. We shade that area in. See? We just ask ourselves which half plane contains the solutions. All right? So those are boundary lines and half planes, and that's how we can do a dashed line if the answer is not included on the line, or a filled in line if the answer is included because it says or equal to. All right? Our next video, 9.6a, we're going to graph systems of linear inequalities. And like I promised, there'll be a link on how to do these function tables, but you really should know how to do that by now. But it'll just take you a couple minutes to catch up. And if you want to know about conjunctions and disjunctions, or set builder notation, or the previous video about inequalities in two variables, just click on the link, okay? So I hope this was helpful. I hope you're doing all right. And keep trying. You'll be fine, all right? I believe in you. You'll get through it. Bye.